So hello and welcome everyone. Welcome to Kreatryx channel. So first of all, let me introduce myself. My name is Vishal Soni and I have cleared engineering services examination 2 times from electronics and telecommunication branch, both times in double digit rank. In 2014 my rank was 98 and in 2015 my rank was 25th. I have served as a Group A Gastro Officer in Indian Railways and in Indian Telecommunication Services. So most of you must have been following me on the Kreatryx channel for electromagnetic field theory. So if you are a seeker of a free education, this is the channel for you, and you must understand that all these free initiatives is coming your way because of the Unacademy. So Unacademy is the revolution in the field of the free education and the affordable education. So how can you access those free courses? So if you want to access the free courses, you must immediately subscribe this channel, Kreatryx channel, because all the top educators of the country is providing the free course on this channel. And that free course is absolutely brilliant in content, that is systematic, that is organized, and that is complete. So complete playlist you will be getting of a particular subject. You can develop the concept, you can gain confidence. More than that, you can love the subject. So immediately subscribe this channel. Secondly, if you want to access more free content, then you must immediately download the Unacademy Learners app, because on the Unacademy Learners app, top educators of the country are conducting the free special classes. In that free special classes, you can get topic wise clarity of a particular concept. And do not forget to follow me on the Unacademy Learning app. So you can also access the courses. So you must have two things. First is your YouTube channel. This YouTube channel, Kreatryx YouTube channel, must be subscribed. Secondly, you must understand that you should have the Unacademy Learning app. That is must for you in order to crack the examination. So these are the parts of the free education. And if you want to organize your content well, if you want more comprehensive manner, if you want other advantages of the Unacademy, then what are the other initiatives that is running by the Unacademy? So another initiative that is running by the Unacademy is Unacademy Plus. So on the Unacademy Plus, this is very affordable for those who actually want to take their preparation to the next level. So आपको Unacademy Plus में क्या क्या मिलेगा? You will be getting the live classes on a fixed time, so that you can get more disciplined, you can get more organized, and you have something in your mind that at this particular time my classes are going to run. Apart from that, you will get free test series designed by the educator itself. So gone those times when we have lot of errors in the test series, we do not have the discussions of the test series. So there the test series will be conducted by the educators. They themselves will be discussing the solutions of that particular thing. So you can imagine that your preparation is going to the next level for this. Apart from that, those who have prepared themselves for the examination, so for them there are crash courses also available. Again the crash courses will going to help you in achieve good ranks. Those who have already achieved good ranks and want to improve their rank, for them there are rank improvement batches. More than that, you can also see that there are unlimited practice sessions. So what do you understand by unlimited practice session? Which means there will be various doubt solving sessions. Apart from the doubt solving sessions, there are weekly quizzes, and with the help of those weekly quizzes you can enhance your problem solving skills. So lot of unlimited doubt solving sessions, lot of quiz sessions, systematic content, structured content. You can download the PDF after the lectures, so you don't have to waste your time in order to making notes. You can utilize those times to practice the particular concepts, or you can use those times to just write down the formulas so that you can remember those formulas quickly. Apart from this plus subscription, there is also one subscription which is known as Iconic. So Iconic subscriptions are for them who actually do not have the self motivation but having the talent. So if they are having the talent and you do not have the self motivation that how can I push myself to crack the examination, so in this Iconic subscription you will be assigned a personal coach. So this personal coach is going to be with you every time, and he will help you to achieve your dreams. You will get a study planner which will be customized for you. You will get the expert guidelines who have already topped the examination. They will be basically hand holding you to crack the examination. So if you think you are not self motivated, if you think you do not have the proper background to crack any particular competitive examination, so this Iconic subscription is must for you. This is going to help you. So if you want the free education, then YouTube channel and the special classes are must for you. And if you can afford a little bit, how much you should afford, that we'll discuss in a while. But if you can afford a little bit, you should come on to this Unacademy Plus. And more than that, if you want the expedited process in your preparation, आप जल्दी से एग्जाम निकालना चाहते हैं, जल्दी से अपनी गलतियां सुधारना चाहते हैं, so this Iconic subscription is for you. Then now let us start today's lecture, which is on the communication system. So now let us start the lecture.
Hello friends, so welcome to the lecture of the communication system. So till now we have studied some basics of signals and basics of systems. Also in the last class we introduced Fourier transform and we said that it is a tool to convert a time domain signal into frequency domain signal. Now in this class we want to learn a very important topic, that is conversion of x omega versus omega graph to x of f versus f graph. So this conversion I am dividing into two cases. First case is when no impulses are present in x omega versus omega. So what will be our steps? First of all, we will divide the horizontal axis omega with 2 pi to make it horizontal axis as f. Then the vertical axis 0 frequency value remains as it is. We know that if omega equal to 0, then omega becomes 2 pi f. So whenever omega will be 0, f will also be 0. Or I can write the value of x omega at omega equal to 0 is quite similar to value of x of f at f equal to 0. And lastly, to represent the dummy variable of omega in x omega is simply replaced by f, or we can simply write x omega to x of f. Let us understand it by an example. Suppose this is our graph x of omega versus omega, and this frequency is minus 2 pi, this frequency is 2 pi, and the 0 frequency amplitude is x of 0. Now I directly want to convert this graph to x of f versus f. So first of all, the shape of the graph does not change. What I will do, I have observed that there are no impulses present in this x omega versus omega. So I will simply replace this x of omega to x of f. I will divide the horizontal axis by 2 pi. Now if I will divide this horizontal axis by 2 pi, this axis becomes f. This 2 pi divided by 2 pi becomes 1, and this minus 2 pi divided by 2 pi becomes minus 1. And in this case I have already stated that the 0 frequency value remains as it is. So this is the direct conversion process from x omega versus omega graph to x of f versus f. Now let us discuss the second case. In the second case, we are discussing that when impulses are present in x omega versus omega. So in this case, the first step remains same, that horizontal frequency axis omega is divided by 2 pi. Also, the vertical axis which represents the area of the signal is also divided by 2 pi, because we know that del omega can be written as del of 2 pi f, or I can write it as 1 upon 2 pi del of f. So this 1 upon 2 pi factor in area, here area is 1 and here area is 1 by 2 pi. So this 1 by 2 factor comes in the area. Now third step also remains same, that dummy variable omega in x omega is replaced by f to convert it x of f versus f. So let me give an example. So this is our x of omega versus omega graph. This frequency is 0, this frequency is 2 pi, this is minus 2 pi, and areas I am writing here as 4 pi. Now I want to convert this graph into x of f versus f. So first of all, I have noticed that impulses are present in x omega versus omega. So first step remains same, that I will replace this x of omega simply by x of f, and the shape of the graph does not change, so I am not changing the shape. Impulses will also be present. The horizontal axis will be divided by 2 pi, it becomes f. So I will divide it 2 pi divided by 2 pi, it becomes 1, minus 2 pi divided by 2 pi becomes minus 1, and 0 divided by 2 pi becomes 0. Now if impulses are present, we are bound to divide the area also by 2 pi, so it becomes 4 pi by 2 pi, it also becomes 2, and this area 4 pi divided by 2 pi will also becomes 2, and our graph looks something like this. this is x of f versus f. So this is 0, 1, minus 1. This area will become 2, 2 and 2. So whenever impulses are present, we need to divide the horizontal axis by 2 pi, also the areas of the impulses also by 2 pi, and this x omega will also be represented by x of f. So this conversion process will help us in drawing this x omega versus omega graph to x of f versus f graph directly. Now let me give another example. Suppose this is x omega versus omega, and our graph is something like this. This value is 4 pi, this value is 2 pi, this is minus 6 pi, minus 4 pi, 4 pi, and this is at 6 pi, and the zero frequency value is x of 0. Now I directly want to convert this graph into x of f versus f. So I've observed that from minus 4 pi to 4 pi no impulses are present, and impulses are present at 6 pi and minus 6 pi. So first of all, what I did, I simply replaced this x of omega to x of f. Now as the shape of the graph will not change, so I have drawn the shape as it is. Now to make this axis f, I will divide omega by 2 pi. Now if this 6 pi is divided by 2 pi, it becomes 3. Minus 6 pi is divided by 2 pi, it becomes minus 3. This minus 4 pi divided by 2 pi becomes minus 2. And this 4 pi divided by 2 pi becomes plus 2. The zero frequency value will not change because the impulse is not present at 0. Now wherever impulses are present, we will divide their amplitude also by 2 pi. This amplitude is also divided by 2 pi, so it becomes 2, this becomes 1, and this amplitude becomes 2. So this direct conversion process we must be comfortable with. Now in this topic we just want to study the Fourier transform of few standard signals. So first signal I am stating is unit impulse signal. We know that unit impulse signal is represented by del of t. So the Fourier transform of del of t becomes 1. So what will be the Fourier transform of a del of t? It will again become 1. We have already stated that Fourier transform is a tool to convert time domain signal into frequency domain signal. Now if someone asks me what is the frequency in del of t, so this is the graph of del of t. We have already stated that we cannot tell the frequency of any signal by its time domain representation. So the frequency of del of t cannot be tell just by looking its time domain graph. We must convert this time domain signal into equivalent frequency domain signal. So we have already understood that the frequency domain representation can be obtained by obtaining the Fourier transform. So if this signal is x of t, then its Fourier transform will become x of omega, and the value of x of omega is 1. So this is the frequency domain representation. Now what is the frequency contained by this signal? We cannot tell just by looking at time domain, so we converted this signal into equivalent frequency domain signal. Now just by looking at frequency domain signal, now I can tell about the frequencies. In the frequency domain signal, this signal is containing all the positive frequencies continuously from 0 to infinite. Whenever we talk about the frequency content of a time domain signal, we strictly calculate the frequency that is positive. So whenever any time domain signal is given and we need to calculate their frequency, then first of all we will take their Fourier transform. and we will see the Fourier transform which is present on the positive frequencies. So this particular signal contains all the possible practical frequencies continuously from 0 to infinite. So what is the frequency content of del of t? It is containing all the frequencies from 0 to infinite. Now if I want to convert this x omega versus omega to x of f versus f, since no impulses are present in this x omega, so what we will do, we will simply replace this x omega by x of f. The zero frequency value does not change and horizontal axis is divided by f. Next important signal is DC signal. So if a signal is given as x of t equal to 1, we know that the Fourier transform is 2 pi del omega. So this is our signal in time domain, x of t versus t 1. Now if someone asks me what is the frequency component present in this time domain signal, so our first answer should be that we cannot tell the frequency component just by looking at this time domain representation. We need to calculate the equivalent frequency domain representation, and for that we will use a Fourier transform tool. So after calculating the Fourier transform, this x of t is converted into x omega, and we have already written that x omega is nothing but 2 pi del omega. So the graph of 2 pi del omega will be something like this. It will be present at origin and it will have an area of 2 pi. So the frequency of x of t will be calculated by x of omega, and in this graph we are seeing that the frequency component is present only at omega equal to 0, or we can say that the frequency content of x of t is 0 Hz or 0 radian per second. And this we already know that what is the frequency of DC signal. So we know that DC signal's frequency is 0, and Fourier transform also stating the same point. So whenever we need to calculate the frequency of any time domain signal, we have to calculate the frequencies present in Fourier transform. Or alternatively, I can say that for any time domain signal, the frequencies present in Fourier transform of xt, and strictly these frequencies must be positive. Another statement I can say that we have to consider those frequencies at which component or components exist in Fourier transform of xt. So till now we have filtered our discussion that if we want to calculate the frequency of a time domain signal, we will calculate the Fourier transform and we will see the frequency components at which the x omega is existing. Now another important signal is cos omega naught t. So cos omega naught t can be written as e power j omega naught t plus e power minus j omega naught t by 2. We know that frequency domain representation or Fourier transform of 1 is 2 pi del omega. So the Fourier transform of e power j omega naught t will be 2 pi del of omega minus omega naught. Frequency transform of e power minus j omega naught t will be 2 pi del of omega plus omega naught. So if I will add these two and divide by 2, so on the right half side or in time domain we get cos omega naught t, and in frequency domain we get del of omega minus omega naught plus del of omega plus omega naught. Now if someone asks me what is the frequency present in cos omega naught t, so I cannot tell just by looking the time domain representation. I will convert it into equivalent frequency domain signal. and in the frequency domain signal there are impulses present at omega naught and minus omega naught, and the area of the impulse will be pi. So what is the frequency present in this time domain signal? To calculate the frequency domain, we have taken the Fourier transform. Now we are searching for the frequency at which component is existing. So in x omega versus omega graph, there is only single frequency at which component is existing. So the frequency of cos omega naught t becomes omega naught, and this is the only positive frequency at which components are existing. So I hope till now we have made a basic approach to calculation of a frequency, that the Fourier transform must be taken and we need to search those frequencies or those frequency components which are present on the positive side. Next important signal is sine omega naught t. So the Fourier transform of sine omega naught t becomes pi del of omega minus omega naught minus del of omega plus omega naught, and this will be divided by j. So the derivation can also be done, but I'll suggest that we need to remember it directly. Next very important signal is a rectangular pulse. So this is the rectangular pulse. This rectangular pulse must be even in nature. So this point becomes minus t by 2 and this point becomes capital T by 2 and the peak value becomes a. Now we need to calculate its Fourier transform. So to calculate the Fourier transform of this rectangular pulse, I am developing a technique. If I will calculate the area of this pulse, then area becomes 80 and the width becomes capital T. So to write the Fourier transform, first of all I will write the area here, which is 80. Then I will use a sampling function, and obviously if this is x of t, then this will be x of omega, so it must be some function of omega. So I'm writing omega here, and with omega I'm writing half of the width, and area is coming here. So for any symmetrical pulse, the Fourier transform x of omega will be the area of the pulse, which is 80, sampling of omega half of the width. So this we must remember correctly. Now if this pulse is given, and we need to calculate the frequency of x of t, or the frequencies present in x of t. So our first answer should be that just by looking this time domain signal, I cannot tell about the frequency. So I need to convert this time domain signal into equivalent frequency domain signal. So I've already calculated its equivalent frequency domain signal, that will be AT sampling of omega t by 2. We know that how to draw the graph of a sampling signal. So shape we know that, we just have to calculate the zero cross over frequencies. So to calculate the zero crossover frequencies, we know that in sampling of t, the zero crossover frequencies exist at t is equal to n pi, where the value of n is plus minus 1, plus minus 2, plus minus 3, and so on, and n equal to 0 is not allowed. So to calculate the zero crossover frequency here, we will put omega t by 2 is equal to n pi, and from here we get the frequencies as 2 pi by t multiplied with n, and n can be plus minus 1, plus minus 2, and so on. So the graph which comes out to be the frequency domain representation of x of t is very interesting actually, and this x omega graph will have a shape of sink. Peak value of sink is 1, but it is scaled by 80, so it will be 80. Maximum value will be at f equal to or omega equal to 0, and 0 crossovers are present at 2 pi by t, 4 pi by t, minus 2 pi by t, minus 4 pi by t. So the frequency domain representation of this rectangular pulse comes out to be a sink function or a sampling function which has 0 crossovers at integer multiples of 2 pi by t. So it becomes 0, the peak value is 80, this 0 crossovers becomes 2 pi by t, this is minus 2 pi by t, this is 4 pi by t, this is minus 4 pi by t, and so on. Now if I want to convert this graph into x of f versus f, so I have noticed that there is no impulses present, so zero frequency value will remain same, the shape will also remain same, and horizontal axis will be divided by 2 pi. So if we divide the horizontal axis by 2 pi, this point becomes 1 by t, this becomes minus 1 by t, this point becomes 2 by t, this point becomes minus 2 by t, or I can say that the zero crossovers in hertz will be integer multiples of 1 by t, or I can write it will be integer multiples of 1 by width. So if I see the width in time domain, so it will be 1 by width in time domain. So this is very important conclusion, that the Fourier transform of a rectangular pulse will always have a shape of sink, and the zero crossover frequencies will be integer multiples of 1 by width. Now if I need to calculate its frequencies, so I have converted this time domain signal into equivalent frequency domain signal. Now I will search for those positive frequencies at which component exist. So if I look closely, then at all positive frequencies in some or other form the components are existing, or I can say that this x of t signal also contains all the frequencies from 0 to infinite, and in between at some frequencies this signal is becoming 0, and those frequencies are integer multiples of 1 by width. So this signal is very important, and we must remember all the properties of a rectangular pulse. Now let us solve a question. In this problem it is saying that a binary pulse of duration 10 unit is shown where are the zero crossover instances present in the given signal. So it is asking about the zero crossover frequencies which are present in this signal. So if it is talking about frequency domain analysis, we cannot tell just by looking at time domain signal, but we observe that it is nothing but a gate pulse or a rectangular pulse which is even in nature. So I have simply calculated its width. Width is coming out to be t. So in x of f it will have zero crossovers at integer multiples of 1 by width. So the zero crossover frequencies comes out to be 1 by 10, 2 by 10, 3 by 10, 4 by 10 and so on. So these positive frequencies comes out to be zero crossover frequencies. So for these questions we have directly used the results which I have concluded. Another important signal is sine 80 by pi t. If a signal x of t is given as sine 80 by pi t and we are interested in frequency domain analysis of this signal, so the frequency domain representation of this signal becomes a rectangular pulse in frequency domain, and this a will represent the frequency, so it will be lying from minus a to a, and sine 80 by pi t format will give us the magnitude 1. So what it is saying that if there is a pulse in time domain signal as sine 80 by pi t, then the frequency domain representation will always be written as, we will look for this a. If a is obtained, then we will make a rectangular pulse from minus a to a, and sine 80 by pi t form will already ensure that the peak value should be 1. So if someone asks me what is the frequency content present in this signal, so for the frequency content we cannot tell just by looking at time domain signal. So I've taken the Fourier transform and got this signal. Now I will search for those positive frequencies at which component exist. So these are the positive frequencies. So the omega will be from 0 to a. Now if I want to convert this x of omega versus omega into x of f versus f, so what I will do, no impulses are present, so I will simply replace this x omega to x of f, and I will divide the frequency axis by 2 pi, and zero frequency value will never change. Suppose if a function is given as sinc of t, and we have to calculate its frequency. So first of all I will write sinc function as sine pi t by pi t. We can see that it is in sine 80 by pi t representation and value of a is pi. So there will be a rectangular pulse in frequency domain from minus pi to pi, and since the division term is already pi, so it will ensure the value should be 1. If I convert this signal into frequency domain, so it will become x of f versus f minus 1 by 2 plus 1 by 2 1, because this axis will be divided by 2 pi. Another example I can show as, we have to calculate the frequency of sine 2t by t. So it is not in sine 80 by pi t format, so what I will do, I will divide and multiply by pi. So it becomes pi sine 2t by pi t, and this format is sine 80 by pi t, and value of a is 2. So in frequency domain, this will have a rectangular pulse from minus 2 to plus 2, and if sine 80 by pi t format retains, then the value should have been 1, but it is also being multiplied by pi, so the peak value will becomes pi. Another important concept is absolute bandwidth of a signal. So whenever we want to calculate the bandwidth of a signal, then first of all we will calculate its Fourier transform, and we will get x of omega. Now in x omega graph, the frequency is obtained or observed. Now the bandwidth is highest positive frequency at which component exist minus lowest positive frequency at which component exists. So this is very important definition, and you must notice few important keywords: that highest positive frequency at which component exists minus lowest positive frequency at which component exists. So we will observe those frequencies which are positive as well highest. Also the component should also exist at that frequency. And another frequency that we will search for is lowest positive frequency, and also at that frequency component must exist. Suppose we have to calculate the bandwidth of sync t. So what I will do, first of all I will calculate the frequency domain of sync t. So it can be written as sin pi t upon pi. So it becomes the format of sin 80 by pi t, and this is the value of a. So we will make a rectangular pulse from minus pi to pi, and peak value will become 1. So what will be the bandwidth of sync t? The bandwidth will be highest positive frequency at which component is existing, pi, minus lowest positive frequency. Here lowest positive frequency is 0. You should not take this minus pi into consideration because this is not positive. We have to restrict our calculation to positive frequencies only. So highest positive frequency at which component exists is pi, and lowest positive frequency at which component exists is 0. So the bandwidth of this signal becomes pi radians per second, or if I want to calculate it in hertz, so it becomes 1 by 2 hertz. So this is the exact procedure for the calculation of absolute bandwidth. Another example we can understand. Suppose if we have to calculate the bandwidth of sin 2t by t. So this is also in sin 80 by pi t format, but pi is not present here, so I will divide it by pi and multiply it by pi. So this format is sin 80 by pi t format, and this is the value of a. So I will make a rectangular pulse in frequency domain from minus a to a, and it will be x of omega versus omega, and peak value is divided by p. Now what will be the bandwidth of this signal? The bandwidth will be highest positive frequency at which component exists minus lowest positive frequency at which component is existing, and it becomes 2 radian per second, or if I want to calculate it in hertz, so it becomes 1 by pi hertz. So that's it for today's lecture. Thank you.
So if you have liked today's lecture and you want to subscribe to Unacademy Plus, the very first thing that you should understand that you should use this particular code. What is the code? The code is VishalGate. Write my name and attach GATE to it. So by using this particular code, you will be getting all the advantages of the Unacademy Plus. All the added advantages will be directly assigned to you. Secondly, you will directly come to under my guidance, and that will surely help you to crack the examination in the least possible time, and you will also get the guidance of the complete team. Okay, and the most important thing is that you will immediately get the 10% discount on that. So immediately you are enabled to get 10% discount once you use this coupon code. So for example, if you talk about the plus subscription, which is costing you 25,000 for 1 year, and if you use this coupon code VishalGate, immediately you are going to get 10% discount, which is 22,500. And if you talk about the iconic, for the iconic subscription of the 12 month, this will cost you around 40,400. So these are the cost of the 12 months. And if you want to talk about the 2-year subscription cost of the Plus, it is your 27,000 after discount. If you want more discount than 10%, and you have already attended the special classes, then you will be having some credits in your account. Do not forget to use those credits so that you can get more discount than 10%. Now, how can you pay these amounts? So there is one good news for you, that you can pay this amount by using credit cards and debit cards by using the facility of the zero cost EMI. So if you want to pay this particular amount of 22,500 with the help of zero cost EMI, so the zero cost EMI can be availed by using credit cards and debit cards. Remember, you can use the credit card of any company, but the debit card is allowed for HDFC and the Bajaj Finserv. Apart from that, if you want to directly pay this much of amount, you think that this particular amount is the most affordable fees that can be provided to you for 1 year subscription, तो आप directly क्या कर सकते हैं? You can use this credit card, debit card, direct payment. You can also go for the EMI options, okay, and you can directly pay this amount by using net banking. Every time you think of the Unacademy Plus subscription, the first thing that should come in your mind is this particular code. Do not forget to use this code once you take the subscription, because I have already told you that this particular coupon code is going to give you the lot of advantages, so you cannot miss the opportunity to use this code. So every student who want to come on to the Unacademy Plus, they want to take the advantages of the Unacademy Plus, they want to empower themselves in the best possible manner in this digital era, they want to be the part of this revolution, then this is the time for you. You do not have to wait for it. If you are in the first year, if you are in the second year, you are in the third year, the best possible time is right now to prepare for the examination, to dedicate yourself, to give yourself the opportunity so that you can get the success as early as possible. Apart from that, you should also join this GATE aspirant group. So this GATE aspirants group is already having 150k plus students, so you can join it. There are a lot of discussions going on between students. You can get the advantage of those discussions. Okay. You can also join this Kreatryx channel, which is a Telegram channel. So everyone has to join this channel so that you can get all the PDFs of the lecture which is being assigned to you. Fine. There are various channels which you can go for it. So various channels in the association with Kreatryx. So you can follow the channel of your interest. And this is it in today's lecture. So let us meet in the next lecture. Thank you so much.